Hi everyone, welcome to CSM walkthrough for E16B. This is week 3 and we will cover question 2, part A in this video. I'm Jiu. Okay, so I will skip the mini lecture and the review on the phasors and complex numbers, assuming that you already know that from last week and this week, question 1. For this question, we will see the circuit, this RLC circuit, where we're given the resistance, the impedance, and the capacitance, and we're also given the Vs, which is the voltage input. And we notice that it's a sinusoidal form, so we are allowed to use phasor analysis. Okay, so Vs phasor is equal to 5. We know that this is equal to 1/2 V naught, which is used for the magnitude. So okay, V naught e to the power of J phi, the phase for phi. V for phase. Okay, and so plugging the information from the given, we plug 5 into our V naught and pi/4 for our phase. And we know that our actual 5 cosine, this will be the real part of our 2 times Vs phasor times e to the power of j omega t. Again, putting the information from the given into here. So we know from the given that our phase is equal to pi/4, V naught is equal to 5, and our frequency is equal to 1,000. So we put 1,000 in here. Okay, this is what we got. And our part A asks us about the impedances. So remember, for the impedance of a resistor, we just have our R, which is just 3,000 ohms as given here. For the impedance of the inductor, we have j omega L, which is just J times the 1,000 times L, which is 10 to the power of -3. Okay, that would just be 1 J, so J. Finally, the impedance for the capacitor will be 1/j omega c. Remember, all these formulas might be useful for a cheat sheet, or you could just memorize them. But anyways, plugging in the numbers, we have 1/j 1,000 times the capacitance, which is 10 to the power of -7. So that would just be, but we don't want our j to be in the denominator. So we could bring this to the numerator by multiplying j/j, which is a 1. So we're allowed to multiply them and get the same number. And j times j is just -1. So we have j over 10 to the power of -4 but 10 to the power of -4 is just equal to 10 to the power of 4. So we have this as our capacitance. As our impedance for the capacitor.